I'm Sky Taylor, an Industrial and Systems Engineering student graduating in the spring of 2022, and I am an undergraduate researcher in the My Music Machine Lab.
Hi, I'm Caitlin Sanford, and I'm a sophomore in Industrial Systems Engineering with a computer science minor, and I'm an undergraduate researcher for the My Music Machining Lab.
Hi, I'm Jing Zhang. I'm majoring in human factors in the SE department. I'm a graduate researcher in the My Music Machine Lab. Currently, the three of us are working in the lab to study the in-vehicle agents in the automatic driving system.
Our projects focus mainly on conditional automation, meaning that the in-vehicle agent will request that the user takes over control of the vehicle. However, the vehicle is fully capable of driving entirely by itself. Our first project started in the spring of 2021 with the intention of investigating the effects of an in-vehicle agent's transparency depending on the level of information that's provided to the user, combined with that agent's reliability, as in how accurate the information presented is.
A motion-based driving simulator NerveTech was used to simulate the driving scenarios. The simulator consists of three 48-inch Samsung displays that covers a 120 horizontal field of view, a steering wheel, an adjustable seat, pedals for gas and brake, and throttling sound equipment. The message from the driver to take over will be like, please take over and please re-engage the auto drive when it is needed. And the way to take over is pulling the wrench on the right of the steering wheel toward their body, and they do the same thing to re-engage the auto drive. When they drive, the in-vehicle agent will give them information on navigation, different road events, and weather conditions. Here is a demo of driver in pull condition. Unlike push condition, in which demo provides the user with all information about a certain situation in one string, in pull condition, unlike what is happening or what to do information is initially presented to the user. The user can then request the agent to share why and how information by seeing the face. More information.
Please take over.
More information.
It is expected to swerve in 1,000 feet.
My study keeps previous research designed to study the effect of reliability and transparency of the in-vehicle agents on driver's response, with an additional trust questionnaire to explore cognitive trust and affective trust, and an advanced physical sensor, which is adapted to collect the physiological data from the driver. The advanced physical sensor we adopted in current study is called Empatica E4 wristband. It is able to collect physical response of blood volume pulse, heart rate, skin temperature, galvanic skin response, and accelerometer. In the study, we aim to explore the use of such device in dynamic driving environment of detecting driver's workload, driver's performance, compliance, and trust by using physiological measurement collected from the wristband.
For the project that I'm working on, we edited the experiment design of the previous projects to look at the effects of emotion instead of transparency on trust and driving performance. In our most recent study, we maintained the independent variable of reliability and introduced the variable of emotion. We assessed the effects of three different emotional conditions and two types of in-vehicle agent reliability on trust in Level 3 automated vehicles. The participants drive in two different driving scenarios after the emotion induction, and then further answer questions about their perceived workload and agent characteristics.
The results of our study showed us overall that the unreliable agents resulted in less compliance with the requests to take over, as well as poor takeover performance, meaning that the time to take over was longer, and then while the participant was in control of the vehicle during that takeover period, they typically drove faster, which is associated with riskier driving behaviors. This definitely tells us a lot about what we need to know when we're considering designing user interfaces in autonomous vehicles and the levels of transparency and reliability that are required to have the user perform well and trust the system that they're working with.
By adding the questionnaire of cognitive trust and affective trust, we can further explore where the influence of reliability and transparency on driver's trust comes from, whether they have effect on driver's cognition, as in knowledge and ability on the driving system, or driver's effect as in emotional aspect of the system.
The reliability and emotion study will provide a deeper understanding of how drivers perceive an automated vehicle and its agent depending on specific combinations of multiple factors. We will be able to understand how drivers' emotions, both positive and negative, and system reliability can influence drivers' trust towards the automated vehicle system, as well as takeover performance. This research can be used to provide practical guidelines on the design of empathic automated vehicles for better user experience while driving.